Okay, digital design and BIM. Why? Why design computing? Why digital design? And what is BIM? That's what we have walked through. Last semester, even when you were a freshman, using SketchUp, AutoCAD, something like that, exactly same or similar situation to this guy, using several visualization, geometric tools, we have generated something like this image. Of course, this is professional, okay? Professional, some commercial, IKEA, product presentation purpose, the professional visualization. But anyway, we are trying to visualize design, okay? Your design studio, in your design studio. In near future, in your design firm, design company, you have to visualize your design concept and the progress, merits, advantages, effects, and so on, okay? That's why we are dealing with such computing tools, applications. But actually in this semester, this is the same slide that I show you at the beginning of this semester, okay? At the first day of this semester. This course consists of design computing theories and lab exercises, including applications, Revit, Family Editor, and Grasshopper, Dynamo, and some 3D visualization tools we already have learned mentally in 3D Max using Autodesk material and so on. And their interoperability, okay? Interoperable visualization and work. Actually, we not yet reached to this area, movie making, but actually last semester in 3D Max course, we have learned how to make 3D Max based animation and so on. Anyway, this semester we are going to handle some more applications next week. But anyway, it's time to review, okay? It's time to review. Based upon this history of design and computing, let's take a look back. Some fundamentals again. When you have learned this theory, this approach, actually before learning BIM, before handling Family Editor, Dynamo, parametric modeling, before understanding what is parametric modeling, what is object-oriented design, before knowing Revit, it's not easy to figure out the slides and the content that I show you. But I believe now you can figure out why we need to take and follow this kind of sequence, regarding some history of design computing. I told you history of design computing, history of CAD, but actually it's not a history because it's very short, just 40, 50 years, right? Compared to architecture history, compared to human history, several thousand years history. I'm not talking about that thousands of years. I'm just talking about 40, 50 years, okay? Computing power needed for CAD. For computer design, even 70s, the early phase of CAD, we need some power. Now we need a lot more power. But actual computer power available, represented in blue line, okay? Take a look. Always insufficient, okay? Insufficient. It's not enough, always. But how about nowadays? Okay, I know it's expensive, but in this time, in this area, in this period, it's not a matter of money, okay? In this year, really, really amazingly expensive money, as well as they need a building, okay? Computers sometimes bigger than buildings, okay? So it's not affordable to individual for design company. But nowadays, just buying expensive laptop or computers, and then you can do anything. So according to this some historic things, what happened before and after 2000? GPU, okay? A lot of parallel computing implemented inside of graphic processor unit, and Pentium 4 and multiprocessor, multi-core CPUs available, as well as very, very cheap computer memories, So nowadays, anyone use giga memories. But actually, they don't need gigabyte memories. But now we have gigabyte memories. So that kind of changes enabled us to use BIM. What is BIM? Simply say, BIM requires bigger power, okay? Heavyweight applications. BIM requires expensive laptop, okay? Expensive computers. Simply compared to games, okay? StarCraft 1 requires very cheap computer, hardware specification, but StarCraft 2 requires kind of expensive computers, okay? High-speed multi-core CPUs and good GPU and more memories, okay? That simple comparison makes you realize this chart, okay? Anyway, early phase of CAD system, even first 3D building model formed in middle of 1970s. At that time, personal computers not available, okay? But nowadays, your laptop, my laptop, enabled to run Revit without any problem, okay? That is why BIM or even advanced computing technologies applications are available without any problem. Simply say affordable, okay? Within your hand. So that's why this is the kind of the moment when the BIM is available to public, okay? Even 1970s, 80s, the concept and approach of BIM already formed by researchers in university. Some leading researchers, developers. They already developed some BIM-related system, but no one could use BIM, okay? Because of this gap. But nowadays, no problem, okay? Your computers are affordable to use such technologies. As you remember, according to how we understand what is design, in all the time, okay? Actually, not all the time. 40, 50 years ago, even nowadays, somebody believes that this is design, okay? What is this? 2D drafting, okay? Front view, top view, left view, right view. Such industry standard 2D draftings are design. Some old people, even nowadays in your design firm, they still believe this is design, okay? If you are working with 3D SketchUp model or other 3D tools, they must say it's not a design, okay? You have to work with floor plan, detail plan, section plan, and so on, okay? But I'm not talking about that kind of industry standard. Someone believes that, and that's possibly right, but it is sure that it's old-fashioned, okay? Your junior students, okay, freshmen nowadays, they gonna learn BIM second year. Next year, or next step to next year, even freshmen going to learn Revit in their freshman course, okay? They're not gonna deal with any AutoCAD drawings in near future, okay, your junior students. So when you meet that kind of junior student workers in your design firm as collaborators, you must find out this kind of approach, okay? Sometimes people neglect this is not a design, okay? That is just geometric symbol, okay, not a design. Anyway, some smarter people invented surface-based 3D, and then SketchUp, Rhino, 3D Max, Maya, such surface-based 3D modeling tool, and their products, computational model, believed as design, okay? But in this semester, we have walked through solid model and parametric model, which is editable, okay? In parametric model approach, we learned we don't need to deal with XYZ coordinate system, okay? It's the matter of mathematics, it's a matter of computer science. We are dealing with width, height, depth, thickness, and some equations, such as Bernoulli or Fibonacci sequence, or your own algorithm invented by you, okay, for developing your design. That is so-called parameter. Your design parameter is going to be used for your design, not your mouse clicks, okay, not by coincidence. Anyway, overall, at the end, even more information can be appended on your computational model, and that is so-called building information model. In terms of process, that is building information modeling, okay? That's why we have learned BIM. We have learned the geometric things. Why BIM is so-called advanced? Before BIM, our focus was on geometric shape. Let computers do what we have drawn. That's the approach of SketchUp, approach for AutoCAD, 3D Max, okay? But how about Revit? Revit is in charge of building lifecycle, okay? BIM is in charge of building lifecycle, not only focusing on design phase. How about SketchUp? SketchUp is in charge of visualizing something. When? Early phase of design or middle of design, not actual construction phase. In that phase, no changes, okay? How about Revit? In construction phase or even in facility management, maintenance phase, we still need some building information, okay? In terms of information management, I already introduced you before. Building information modeling also means building information management, okay? The same M, but not just model or modeling, also management, okay? So we are focusing on information. That's the big difference. So as we reviewed before, some architectural codes, architects approach to building architecture using the concept of space. What is space? Space is an empty area. It's void. It's not touchable. It's kind of non-tangible thing, okay? It's void. But anyway, architects or even philosophers, general people, smart people, they always talking about space, okay? How to waste space, that is architecture, okay? Sounds like something weird, but anyway, that's true. And architecture is a shelter, design of space. Music in space, frozen music. An epoch translated into space. Even Miss Van der Rohe talked about space. But actually, how to represent space in your CAD model, in your hand drawing? When you draw your space design, what you draw? You never try to draw space, okay? Simply because space is empty, okay? There is no way to draw space. So what you draw, what you have to express, bounding box, boundary, height, surrounding walls, openings, floors, furnitures, okay? Or symbols of arrows, flows, connections, topological relationships. There is no space object, okay? Even in your hand drawing, and naturally, nothing in your CAD model. But how about in BIM system? In BIM system, simply say, in Revit, we design using walls, columns, ceiling, slab, furniture, design components, or your freeform object designed by Dynamo or any other geometric tools. But in CAD system, we used lines, polygons, faces, vertices, and so on, okay? So go back to fundamentals. Back to fundamental means back to principle, okay? What is the principle? Here is the principle, okay? Dealing with the space for real architecture. So even up-to-date computer software Revit or similar BIM tools finally implement this principle approach. Okay, that's the so-called BIM approach instead of lines or shapes, spaces. So this diagram shows you that dramatic change in one single page. Okay, this shape is office labeled polygon, office labeled rectangle geometry. But in Revit, this is space object instance, which is containing associated information. That associated information is associated properties. In other words, attributes. Okay? What kind of attributes? Space name, zone name, space number, spatial topology, net area, height, volume, 3D geometric data, and so on. Amount of additional information can be assigned by you. Something auto-generated, something auto-calculated. In Revit, no need to measure height, width, perimeter lines, area. All day auto-calculated, okay? That's the power of BIM, and it's really big change, kind of revolution, okay? But in CAD system, as you know, as you remember, we always have to control sub-geometric components. But take a look, this structure, the same visualization, okay? Exactly same visualization, but here is point and rectangle shape, that's it. But this one has wall object, 1, 2, 3, 4, and space object. And eventually, computer understands this space has been surrounded by 4 different wall objects. And this one knows whether the other space adjacent or not, whether the other space is directly accessible or not through the opening and doors. Okay, that's the BIM. Computationally, very different. Okay. So take a look this hierarchy diagram. As I told you before, the yellow box here is the fundamental principle mechanism how architects, just like you, okay, how to approach to design. Okay, not line composition of lines or spaces in 3D. How about windows and doors? You should understand that for door or window object, we need an opening. And the opening must be installed on top of wall object, okay? Not on slab or ceiling. So this is not the structure how you understand the building. This is the structure for computers. Structure for Revit, okay? In other words, Revit understands this structure and implemented in their own mechanism. Exactly same to architects. But actually in its lower level system, this is the representative data structure for IFC. What is IFC? IFC is an actual building data model as an international standard, okay? So Revit can export IFC file and ArchiCAD, other tools or some BIM tools can import IFC file. IFC file contains everything, technically, okay? So even 600 more entities, one entity means one single box out there, but this one single slide summarize its data structure like this way. Take a look. Exactly same how human understands a building structure. Structure and spatial element under the name spatial structure element, okay? That is why computers can understand very similar way to human, okay? Actually, we reviewed some Google search engine image search or AlphaGo system or some AI-based things roughly. If there is a AlphaGo-like system in CAD domain, as you already experienced, Revit is the application, okay? Not SketchUp or 3D Max. That was the point. So this structure, space, floor, building, and their related associated properties simply listed. And this structure is for for computers. Very similar to humans, okay? That's the point. That's why we walk through Rabbit system, okay? Let's quickly take a look Rabbit. As you open Rabbit interface, this is front page, main interface. As you see, large size icons and very easy to use icons and very intuitive. So most people, when they saw Rabbit interface first time, they feel like this is very easy to use and powerful application. Of course, it's easy, but actually now you understand behind the technologies or some related mechanisms are very complicated, okay? Lots of things out there. Anyway, this one totally object-based, object-oriented modeling approach. We have walked through this one based upon this building project and family editor, okay? Not only project handling, we already experienced some lab exercises dealing with some families, okay, in order to assemble your project. Okay, actually this is not just a file-based system. This one requires some associated metadata system regarding building information modeling approach. So that is why we have looked some project file, template file, family file. Family file is library, okay? You know how to import, export, or download, or your own custom object creation using family editors, okay? Family means library. So we need to understand where is the library folder, how to import Korea standard library, how to import Chinese standard. When you are working with Chinese building, simply say, you're not gonna work only for Korea building, okay? If you hired by some design company, sometimes you need to design a building in China, a building in Japan, building in Singapore, building in Middle East, in the US, wherever. And then you need to change library, template, not only just units or some conventions. Your library files can be reloaded totally based upon your convention for the project. Anyway, Rabbit interface, actually we need to take a look in detail this one. But we should know that we have objects, okay? They are all objects. And if you choose object or click object or select object, property window shows you amount of related information, associated attributes, okay? So-called information, data, using this window. And also project browser shows you lots of views. What is a view? Take a look. Level 1 floor plan is one of the views, not the subject of your drawing, okay? You are not going to work for plans anymore. In CAD system, you usually working for plans. That's the main goal. But in BIM system, in Revit, floor plan is just one of your views. There are amount of more 3D views, perspective views, rendering views, elevations, and lots of sections. Exactly what you want. Okay, let's take a look this some key feature slide. Actually, when I show you this slide, actually at the time I skipped this page without any explanation. But now I think we can take a look this slide, okay? Because you already experienced Revit and knows something about Revit. Firstly, exporting building geometry in DWG, TWF, FBX. What are they? They are geometric file formats, CAD formats. What is the difference between DWG and FBX? DWG actually contains only geometry usually, but FBX supports texture map, lighting, okay? So I told you Revit 3D Max, they share Autodesk material, presets, photometric lights. That is why you can export FBX, your Revit model, directly to 3D Studio Max mental way. Okay, just some edits on photometric lights, and then you can get quite pretty good quality of visualizations, renderings. If you want to export entire information set, in that case, using IFC, okay? IFC file contains everything, supporting interoperable tasks, okay? Space-oriented design approach. It has mass object, space object, and so on. When we create mass, you remember, while we are creating mass, there are points, surfaces, and some geometric edits, modifications. Very similar to geometric tools. And we create family, triangular shape, rectangle shape, frame, and assign building surface using that surface when we are creating mass object. Okay, that's what we have done in lab exercise hours. Auto generation of 2D plans, sections, 3D rendering images. They are subject for auto generation. No need to work for such drawings anymore. Modeling building object geometry in advanced parametric modeling technique. Actually, the term parametric modeling, parametric design is even much broader than simple description. But anyway, you now understand when parametric modeling approach implemented in computation, computer application, you know how it looks like based upon Revit, okay? Without words, you cannot install Windows, okay? That's one single parametric approach. You already know. Supporting .NET plugin development. If you interested in developing or some computer programming, your Revit, your BIM tools going to be really, really enriched based upon your third-party development, okay? Supporting collaboration. Collaboration is a really critical issue as we reviewed in the course. Revit supports centralized Revit model, centralized file, cloud-based rendering, cloud-based file sharing, and so on, okay? Very interoperable. So Revit key features listed in this single page. I think now you can easily figure out what this means, okay? Also, it supports various kinds of visualization tools, styles, rendering, photorealistic rendering. Actually, we didn't take a look in detail, some walkthrough movie making or some other things, but next week, we're gonna take a look some walkthrough movie making or some additional visualization techniques in Revit as one part of video making. Anyway, lots of advanced features already implemented and realized we experienced. So this is mass object we created, handled, and the room object as one of examples of space-oriented approach. When you create room object or room structure or interior components, this is ceiling object case. Auto detection of ceiling based upon space object surrounded by wall object, and then additional components such as lighting objects can be handled like this, and simple installation of camera and 3D visualization, and you know, external library sources such as Autodesk SIG or lots of library website, as well as this kind of third-party vendor website who is providing this kind of library files. And then you can easily load into your project in order to design your components, your elements, and so on, like this way. So, based upon this demo, modeling College of Human Ecology building using Revit project, we already experienced this kind of family editing tool making this custom object. Based upon this floor plan, we installed custom object window based upon your Revit modeling for entire floor. At the end, this model can be demonstrated, okay, in the lab exercise hours. So theoretically, we have learned some separate comparison between design by mouse clicks as well as design by numbers, okay? That's the similar and almost equivalent to the metaphor design by mouse click versus design by numbers is same to design by SketchUp or AutoCAD versus design by Revit and Dynamo, okay? So, as you know, making surface, controlling vertex, moving point and rotating points, rescaling the specific elements and so on. I know this kind of approach designed by coincidence or designed by mouse clicks sometimes very powerful, and someone believes this is really creative task, okay? Something related to human creativity. But the problem of this kind of GUI base, graphical user interface base, in other words, mouse click based design is sort of coincidence based, okay? It's not easy to recreate this geometry again. Take a look. This kind of FFD, freeform deformation in 3D Max, or even in this kind of Rhino and Grasshopper, when this is loaded to BIM to Revit, this is editable in Rhino and Grasshopper, but not editable in Revit because Revit recognizes this one is just a mere geometry, okay, dummy geometry. Anyway, that's why we handled some approach named design by numbers. Actually, I told you before, design by numbers, this phrase, this application coined by John Maeda, MIT Media Lab before, and his successors invented the language processing to draw something like this or something like this approach using this very simple computer program, or even really complicated computing languages going to create this kind of visualization. We reviewed this approach, and there are amount of more examples. Very effective, visually effective, and sometimes beautiful and looking really, really fresh and cool, okay? But the problem of those language is not easy. We are not programmers. That's the problem. So that's why someone invented a visual language. Take a look. This logic, this algorithm can be represented in computer programming language like this way. But this is not easy. That's why replacing this kind of visual representation. Take a look, very intuitive. Input placed left side, output placed right side. What is this one? This is operator, okay? A plus B, A multiply B. That kind of definition can be manipulated by you, okay? This is very simple example, but anyway, in real world, they can be really complicated. For example, we can use Dynamo case for making this one. What you need? Defining one single curve line and sequence of XYZ points in several split points and their variations, okay, using random algorithm or something else. And then you can get this kind of changed geometry. That's the fundamental mechanism of this kind of visual language and tool. In this case, that's Grasshopper, okay? So this kind of Grasshopper can be exported to any geometric file at this time, SAT file, whatever, and then placed into Revit as a dummy geometry. That is not editable, okay? What if this is SketchUp model, 3D warehouse model? What if this is 3D Max geometry? Of course, you can import any geometric model from your SketchUp file, 3D warehouse model file, your friend's 3D Max file, whatever, using geometric file format, whatever. Your Revit can import any type of geometry without any problem. But the problem is this is not editable, okay? So how to edit this kind of structure, this kind of geometry? That is why we have looked Dynamo as a Revit plugin, okay? So Dynamo is another visual language-based design approach, but this one is up to date, okay? This one has powerful support to BIM system. So in Dynamo, the same as Grasshopper is working, the node can be controlled by those additional user interface kind of node, okay? Numbers or number sliders or some functions such as sine formula can be used for your equation to control XYZ coordinate system. At this time, G coordinate system, which means the height of the line curve, okay? According to the Z coordinate system, this one shows certain type of sine graph, okay? That's why we can get this kind of surface. And then we can apply this one for your design, such as surface making based upon your input. In this case, input is this type of bitmap image available net internet or your digital camera. So one single input and entire other algorithm can be defined by one single operation. Okay, this operation's input is picture. What is output? Output is this type of geometry on top of Revit, okay, family editor or Revit project. So you can get this kind of very specialized interior panel, even ceiling panel or even floor, okay? You can get this geometry. So we have looked this case demonstration before and get this kind of sequence of images. If you change the input, of course, output parameter are going to be changed in a couple of seconds, okay? So at the end, I introduced you the use scenario for interior architecture designers, very industry standard oriented and project oriented as well as object oriented approach for designing building using predefined objects such as windows, columns, doors, walls, lots of predefined libraries out there, and you know how to handle families. Family means library, okay, components. Your customized objects can be loaded or even downloaded, okay. There are amount of available libraries are out there. How about very customized freeform shape? For interior architects, we need lots of undefined objects, so-called freeform objects or something very unique and totally brand new objects, okay? Sometimes never sold by anyone, okay? So how to make such things? That is why we are dealing with some external geometric handlers, how to use importing geometries or Dynamo-based geometry making approach, okay? So this is very good and useful scenario for developing your project. Customized and freeform objects, anytime, any geometry can be handled like this way. But for editable geometry, we need to know family editor with Dynamo. That was my point, okay? But even if we are dealing with BIM tools, with digital design software applications, still we need 3D visualizations, okay? That is why we take a look, we need to look and we reviewed some visualization approaches defined in Revit. As you know, this is Revit interface and Revit visualization case. Another Revit visualization, Revit render, photometric render example, but the problem of this render is too slow, too much slow, and computer hardware dependent. So that is why I showed you and introduced you some advanced features and some techniques and tips for saving time or making some efficient and better visualization ways. For example, geometric modeling, not geometric modeling, architectural component modeling in Revit and visualization in 3D Max like this way. What you need to do is modifying some additional features, elements, especially focusing on lighting structure, okay? And you can get this kind of render without any additional material or some unnecessary works. That was my point. Also, we have learned and looked some 3D Max and Mental-A shaders, including today's lab exercise. Even if we postpone lab exercise today to next week, next step to next week, there are amount of presets, Autodesk material. Last semester, we have learned lots of techniques in Autodesk predefined material with presets, but this semester, we need to take a look Mental-A shaders. Actually, we already reviewed some shaders. Autodesk Water is one of the shaders. Okay, next week we're going to deal with some animation making, video making features, animation features in 3D Max as well as in Revit. Okay, if you assign water on top of surface, you can render this kind of surface. What if you check this is animation and render in animation? The surface of this water going to be moving, okay? Just like a tide. If this is ocean, this one is, I don't know how to express that expression. Anyway, this is moving like ocean water or pond lake water. If you simply check animation, even if you don't put any movement or any camera moving or object changes, this one going to be animation because water surface going to be slightly changing time by time, second by second, okay? How about this kind of beam shader? Using beam shader, this is no beam shader render, default render. But if you use beam shader, you can get this kind of visual effect. How about glare shader? This is lighting object, okay? But using glare shader without Photoshop, you can get this kind of visual effect. Thanks to Mental-A predefined shaders. How about this matte shadow reflection map? Okay, take a look. This is 3D Max object or your design scheme, and the background shows your picture, okay? If you have some remodeling or furniture design or whatever, something new, what if you can make a composition with your object with existing picture? Of course, we're going to use Photoshop, but you can render in Mental-A shaders, and then you can get very natural. Take a look, shadow and reflection. They are all generated by 3D Max with this background picture, okay? So this is very powerful shader, okay? Actually, last time we reviewed this kind of shader and more shaders, some outline, okay? We reviewed last time party volume shader, and this is some type of wire render or, okay, where is the, okay, I skipped some more slides, but actually in today's lab exercise folder, there are amount of more examples in 3D Max shaders, such as line stroke, okay? That kind of visualization techniques are still our subject to exercise, okay? That's my point.